I'm going to be doing number 33 from the homework, and 33 says, objects with masses of 200 kilograms and 500 kilograms are separated by 0.4 meters. A, find the net gravitational force exerted by these objects on a 50 kilogram object placed midway between them, and B, at what position, other than infinitely remote ones, can the 50 kilogram object be placed so as to experience a net force of 0? So, just to map things out a bit, I drew this 200 kilogram object, and then it says in the middle of 200 and 500 kilogram object there's a 50 kilogram object, so I drew that here. And then again there's a 500 kilogram object over here. It also says that the 200 and 500 kilogram objects are 0.4 meters apart. Okay, and I'm doing part A now. So for part A, we want to find the net gravitational force exerted by these objects on the 50 kilogram object. So what I first noticed was that if you look at the 50 kilogram object, it's going to be attracted this way to the 500 kilogram object, but it's also going to be attracted this way to the 200 kilogram object. So that means that because they're opposite forces, so I made this side of the force, or this force positive, and I made this force negative because they're opposite. They're facing in opposite directions and the forces are opposite, so you have to change the signs as well. So what I did was I found, let's call this force 1 and this one force 2. So I'm going to solve for force 1 first. So in order to do that, I did this. And then I'm just applying Newton's law of gravitation. And then because it's halfway, this distance is 0.2 meters. And same thing for this. And when I solve for that, I get, let me see. .16875 times 10 to the negative 5 newtons. So you're just going to do the same thing with force 2, except remember that it's negative. And then I get negative 1.6675 times 10 to the negative 5. Oh, and before I forget, G is equal to, or Newton's constant, this constant is equal to 6.67 times 10 to the negative 11. Okay, so now that I have these, they ask for the net force. So to do that, you just add the two. So Fg1 plus Fg2, that you end up with 2.5 times 10 to the negative 5 newtons. Okay, so that's part A. For part B, they ask you to find the position where the 50 kilogram object would experience a net force of 0. So to do that, you have to set these two forces equal to, because as long as they're equal, because they are opposite forces, it'll become a net net force of 0. And the only thing that's changing in both of these equations is the distance, so just the denominator. So you can just keep everything the same, just set it equal. And because we're setting it equal, you can omit this negative sign. So then I'm just calling this radius 1 because we are unsure of like what the radius is going to be. And then I'm calling this one radius 2. So just right there. Okay, so the first thing I noticed is that you can cancel a lot of stuff. Cancel these, and you can also cancel the 50 kilograms. So ultimately, you're just left with this over this, this over this. Because R1 and R2 have to add to 0.4, you know that R1 has to be 0.4 minus R2. So I continue to solve, but I substituted R1 with 0.4 minus R2. Don't forget units like I did. Okay, so just to make the solving a little bit easier, I'm just going to take out the units for now, and then I'll add them back at the end. So then you're just going to multiply, cross multiply, so here to here. Okay, and then you see it's just a quadratic equation. So when you do the math, you end up with 300 R2 squared plus 160 R2 minus 32 equals 0. From here, you are just going to apply the quadratic equation, and when you do that, you will end up with R2 being approximately 0.1549 meters, and because R2 is equal to 0.4 meters minus R1, you can then solve for R1. Then you will get approximately 0.2451 meters.